Explain the video goal and say this will cover the high-level process of designing, sourcing, assembling, and shipping an Android phone, including hardware components, software integration, testing, certification, and after-sales support. Give a simple definition of an Android phone as a smart mobile device that combines hardware components and software based on the Android platform to deliver voice, data, multimedia, and app services. Describe the product planning and requirements stage. Define target users, intended price and feature set, screen size and resolution, target markets and carriers, battery life goals, camera capabilities, durability and repairability goals, and timeline and budget constraints. Introduce the main hardware components in plain terms. System on chip or SoC that handles CPU, GPU and modem, memory and storage for apps and data, display panel and touch controller, battery and power management ICs, printed circuit board or PCB that interconnects parts, camera modules and image sensors, radios for cellular Wi-Fi, Bluetooth and GNSS, sensors like accelerometer, gyroscope, proximity and ambient light, audio components and microphones, connectors and buttons, the housing and materials and antennas. Explain industrial design and mechanical engineering conceptually. Discuss ergonomics, materials and finishes, screen-to-body ratio, thermal management considerations, internal component layout and service access, and protection for water and dust resistance. Describe electronics design and integration at a high level. Explain selecting a suitable SoC and reference board, creating a PCB schematic, layout considerations for signal integrity and enemy, power delivery design, antenna placement and RF tuning, and choosing suppliers for camera and display modules. Emphasize that this is done by trained hardware and RF engineers and design follows vendor reference designs. Explain software integration and the Android stack conceptually. Introduce the Android open source project as the base, device tree and kernel for hardware support, vendor drivers in-house for cameras and radios, bootloader and secure boot, Google Mobile Services if using Play Store, and OEM UI customization and pre-installed apps. Mention the need for ongoing security updates and OTA delivery mechanisms. Discuss supply chain and procurement. Explain sourcing components from qualified suppliers, managing lead times and minimum order quantities, validating component quality, and planning for alternatives. Mention contract manufacturers and the role of assembly partners in scaling production. Outline manufacturing and assembly at a high level without operational detail. Describe surface mount technology for component placement, automated optical inspection for quality control, manual assembly for delicate modules, battery packing and sealing, screen bonding and final enclosure assembly, and factory test stations for basic functionality checks. Explain testing and certification conceptually. List functional testing for display camera, audio and radios, RF certification and carrier certification for cellular bands, electromagnetic compatibility testing, safety testing for battery and charging, environmental testing for thermal and humidity, drop and durability testing, and software validation including corner cases and stability under load. Cover production scale-up and quality assurance. Talk about pilot runs to validate yield, inline quality checks, burn-in and stress tests, tracking defects and corrective actions, and maintaining traceability of components and serial numbered units. Describe regulatory and compliance topics in general. Mention certifications like regional safety and radio approvals, recycling and disposal regulations, and consumer protection and warranty laws that must be followed. Discuss packaging logistics and go-to-market. Explain configuring SKUs for regions and carriers, packaging and accessory selection, distribution partnerships, sales channels online and retail, warranty and returns handling, and post-launch monitoring for defects or recalls. Talk about software maintenance and user support. Describe providing security patches and OS updates, a mechanism for over-the-air updates, collecting telemetry and crash reports, and running customer support channels for repairs and troubleshooting. Mention sustainability and repairability considerations. Encourage using recyclable materials, clear repair guides and spare parts strategies, and designing for energy efficiency and longer software support to reduce e-waste. Suggest safe learning paths and resources. Recommend studying electronics and embedded systems, mobile software development and Android internals, RF and antenna design basics, supply chain and manufacturing management courses, and following manufacturer documentation and industry standards. Summarize the core ideas. Making an Android phone combines product planning, industrial and electronic design, software integration, component sourcing, factory assembly, rigorous testing and certification, and ongoing software and customer support. Emphasize that this is a complex multidisciplinary effort carried out by teams and certified partners rather than a simple DIY project. Visual suggestions for the video input. Show concept sketches and UI mockups, exploded views of phone components, animated diagrams of the SoC and subsystems, footage of PCB design and factory assembly lines without operational detail, charts for supply chain and testing flows, overlays highlighting certification and software update cycles, and end with a finished phone in hand and a note about learning paths. Use this full script as the video input for Pictory.ai to generate an educational explaining about how an Android phone is developed and brought to market.